Hi friends, let's continue with our discussion about reflection and refraction. Next question is, find the focal length of a convex mirror whose radius of curvature is 32 centimeter. Given that R is 32 centimeter, we are asking F is equal to what? We know R is equal to 2F, so substituting for R we get 32 is equal to 2 multiplied by F, or F is equal to 32 divided by 2, because this 2 goes into the denominator, that is equal to 16 centimeter. Okay. Next question. A concave mirror produces 3 times magnified, okay, enlarged real image of an object placed 10 centimeter in front of it. Okay. Where is the image located? So again we have roughly drawn the coordinate system, minus x to plus x, minus y to plus y, and this is a concave mirror. So concave mirror such that all the reflection happens on the negative side of the x-axis. So if the object is placed at 10 centimeter, it means that it is placed in front of the camera. So this is 10 units. But since it is along negative x-axis, it has to be taken as minus 10. Okay. We can use the magnification formula, h dash by h, okay, is equal to minus v by u. Okay. We are given that the magnification is 3 times. Okay. 3 times magnified, which means h dash by h is equal to 3. Okay. The ratio of magnification, or the amount of magnification, the ratio is 3. And given that u, they have given it as 10 centimeter, but we are taking it as minus 10 centimeter. Why? Because it's along the negative side of the x-axis. So substituting, we get 3 is equal to minus v divided by minus 10. Minus minus gets cancelled. V is equal to 3 into 10, that is 30 centimeter. Okay. Now 30 centimeter means this is on the, it came out as positive. So this is on the positive x-axis. So image is formed on positive side of the x-axis, that is behind the mirror. Okay. So that means that the image is virtual, and its position along the positive x-axis, which is behind the mirror, is 30 centimeter. Okay. Describe refraction when a ray passes through a glass slab and emerges out on the other side. How is a mirror different from a lens? What is the effect of ray from a rarer medium? Rarer means thinner, friends, like air, okay, to a denser medium. Denser medium means thicker medium, like water or glass, okay, and vice versa. Okay, so this is the question. The answer is, due to refraction, if a ray of single color travels obliquely from a rarer, thinner to denser medium, the ray bends towards the normal. This is very important. When it goes from a rarer, that is thinner, to denser medium, the ray bends towards the normal. So we have shown this in diagram. You can see that AO is the incident ray, and it is going from air into water. Okay. So when it obliquely hits the surface of water at point O, instead of going straight along this dotted line, it bends towards the normal. See this? Ray OB, which is the refracted ray, is bent towards the normal. Instead of going straight along the dotted line, it has bent towards the normal. Okay. This is what is known as refraction. So when going from thinner to thicker, thinner to denser medium, the ray bends towards the normal. Okay. Due to refraction, if a ray of a single color travels obliquely from, this is the reverse case, from denser to rarer, that is from denser to thinner medium, it bends away from the normal. So you can see this diagram here again. Here we are going from glass to air, that is the ray is in the glass, the incident ray is in the glass, and instead of continuing along its direction, right, because of refraction, it bends away from the normal. Okay, it goes along the direction OB, which is away from the normal. Okay, in the previous case it bent towards the normal, but here in this case it is bending away from the normal. If the ray is exactly along the normal, it continues in the same direction without bending. Okay, so these rays are oblique, which means they make an angle to the normal. If the ray was along the normal, then it would have, continued along the same direction. That is to be noted. Okay. What is the difference between mirror and a lens? See, Note, mirror bounces or reflects the ray back, okay, whereas the lens refracts or bends it and the ray passes through it, okay. So look at this diagram. Here we have a convex mirror, okay. When I shoot a ray which is parallel to the principal axis, it reflects back. So it, see, A, B, I shoot a ray like this, it reflects back where it came from, BG, such that it appears to be coming from the focal point, okay. You have already learned this. Now this is a mirror, but what about a lens? If I shoot the same ray AB to a convex lens, this is a convex mirror, this is a convex lens, the lens lets the ray pass through it, okay. This lens, usually made of glass, this ray, when we hit it here, it lets the ray pass through it, but it also bends it such that a parallel ray parallel to the optical axis, it will bend such that it will pass through the focus, okay. So here AB is not reflecting back, but it is transmitted, but it is bent so that it doesn't go in the same direction, it is bent to go in the BG direction, which passes through F. F is the focus, okay. That has to be noted. Note incident. Now with all this understanding, we can see how a ray which is intersects a glass slab, how it interacts with the glass slab and how it comes out, okay. The incident ray AO1 hits the glass at O1. So this is the incident ray AO1, it hits the glass at O1, okay. So this is air, this is glass slab, this is air again, correct. So instead of going at in its original direction, because of refraction and because it's going from air to glass, it bends towards the normal. You can see that AO1 is the incident ray, whereas the O1, O2 is the refracted or the bent ray, and it's bending towards the normal, okay. Now due to the refraction, instead of continuing along the straight path, it bends towards the normal, and this is O1 to O2. Again at O2, due to refraction, this time it is going from a thicker, denser medium to thinner medium. It is going from glass to air. So because of this, instead of continuing along this dotted path, right, it bends away from the normal along O2G, okay. All right. So you can see that here it bends towards the normal, and at this point it bends away from the normal. So this ray seems to be displaced by this amount. Instead of going in its original direction, now it has bent towards the normal, then bent away from the normal, and then it is come out at some distance from its original direction. Note that AO1 and O2G are parallel to each other. Okay. Describe the refraction via prism. Okay. Note that white light is made up of 7 colors. You can call them Vibgyor. Okay. V stands for violet, I stands for indigo, B stands for blue, G stands for green, Y stands for yellow, O for orange, and R for red. Each color bends a different amount due to refraction. Okay. If you send the ray of single color, then you will get a single ray out. But white light consists of 7 colors. Each color bends a different amount due to refraction. When white sunlight is passed through the prism, each color bends a different amount and gets separated into different rays. Okay. So these 7 colors bend different amounts and get separated into 7 different rays. You can see that this is the prism. Okay. It is a triangular prism. It's made of glass. So you have a ray hitting here, and because of coming from air to glass, they bend towards the normal, but red color bends little and violet color bends the maximum. So you can see this below ray, violet ray, which is bending and coming out here. Red which bends the least, bends here, again bends here and comes out here. Okay. So you get 7 rays here. For clarity, we have only shown the first ray and the last ray, which is the violet and the red. So violet bends the most, indigo bends a little lesser than that, blue bends a little lesser than that, green little less, and finally the red is the one which bends the least. So you will get 7 rays Vibgyor starting from the bottom. Okay, this is how the refraction happens in the prism. Next question, what is law of refraction and what is refractive index? See, the law of refraction states that sine of I, where I is the angle of incidence, divided by sine of R, where R is the angle of refraction, is equal to C. C is the speed of light in air, divided by V, where V is the speed of light in the medium. Okay, and this ratio is known as refractive index of the medium. For example, look at this picture again. Okay, so the light ray, if you shoot from the air, it enters into the medium. Okay, this is air and this is the medium. The medium can be anything. It can be water, it can be glass, it can be diamond, kerosene, whatever it is. Okay, since air is thinner, rarer, and this medium is denser, this ray OG will bend towards the normal. Okay, now there are two angles to consider, the angle AON1, which is angle of incidence, and angle RON2, which is the angle of refraction. Okay, so the law of refraction says sine of I divided by sine of angle R is equal to sine the speed of light in air divided by the speed of light in the medium, which is the ratio is called the refractive index of the medium. Okay. Note that the optical density, ability to bend light, is different from the mass density, which is weight per unit volume. Okay. Kerosene has a mass density lesser than water, but its optical density is greater than that of water. Okay. So optical density and mass density are two different quantities. When we are talking about refraction, we are talking about optical density. Okay. A ray of light in air enters water obliquely. Does it bend towards or away from normal is the question. The answer is ray bend towards the normal because the air is rarer or thinner than water. Okay. Ray enters from air to glass with Ri. Ri is a short form for refractive index. With a refractive index of 1.5, what is the speed of light in glass if the speed of light in air is 3 multiplied by 10 power 8 meters per second. Okay, so we know that from the law of refraction, refractive index is equal to C by V, where C is the velocity of light in air and V is the velocity of light in the medium. So substituting for glass, they have given that 1.5 is its refractive index. So substituting, we get 1.5 is equal to C, we know is 3 into 10 power 8 divided by V, where V is the velocity of light in glass. So V can be taken up, 1.5 will come down. So 1.5 cancels 2 times. So the velocity of light V in glass is 2 into 10 power 8 meters per second. Okay. The refractive index, that is short form Ri, refractive index of diamond, is 2.42. What does this mean? This means, again using the law of refraction, Ri is equal to C by V, that is for diamond 2.42 is equal to 3 into 10 power 8 divided by V, right? So V is equal to 3 into 10 power 8 divided by 2.42. If you take a calculator, you will get 1.24 into 10 power 8 meters per second. When the refractive index is 2.42, it means that the velocity of light inside the diamond is 1.24 into 10 power 8 meters per second. That's what it means. Okay. So next question, what are convex and concave lenses and how they bend the parallel rays? Okay. Here we have shown you a convex lens. Okay. It is a lens because whatever light comes, it lets it pass through it, but it bends it. Okay, a convex lens is a focusing lens. Okay, if you shoot parallel rays, it ensures that it bends it such that the rays which pass through it are bent to the focus. Okay, if you see the convex lens, you can see two radius of curvatures, two center of curvatures. Why? Because this is also a spherical surface and this is also a spherical surface. Both the faces, both the sides of a convex lens are spherical surfaces, and since this is a part of a sphere whose center is here, and this surface is a part of a center whose center is here. Since we have two center of curvatures, we have two focal lengths also. So the light, if you pass it through this direction, it will get focused onto this focus point. If you pass it through this direction, it will get focused onto this focus point. Okay, so for lens there are two center of curvatures and two focal points. Remember that. Same thing for the concave also, but convex is a converging lens. Any parallel rays you shoot at it, it will bend it such that the rays will pass through the focus on the other side. So you can see that it has made these rays converge here. AB will move along BG, it will pass through the focus, and DE will pass along EH. So it will also converge at focus, and all the parallel rays will converge to the focus. Okay. The concave lens, on the other hand, is a diverging lens. What does that mean? If you shoot parallel rays at a concave lens, okay, this is a concave lens, it will bend it such that the parallel rays seem to diverge from the focus point. They appear as though they are diverging from the focal point F1. So AB, a ray which is parallel to the principal axis, which is going through F1 and F2, right? E is bent such that it travels along BG. Okay, you see this ray here, it travels along BG. So what has happened to this ray? It has diverged. Okay, how it has diverged? It has diverged, so when you backtrace it, it hits the focus. So it is as though it is diverging from focal point F1. Okay, similarly look at this DE, it is parallel to the optical axis. It's parallel to the principal axis. Now if DE is shot at a concave lens, it bends it such that it diverges along EH. But how does it diverge it? It diverges it such that the EH appears to come out of F1, okay, which is the focus point. So concave lens is a lens, when parallel rays are shot at it, it diverges the rays, and the divergence, point of divergence, is the point of focus. Okay, the center of the lens, which I am pointing to using the pen, is called the optic center, which is denoted by O. Similarly, for convex lens, the O is this point. I am pointing it out in the pen. Okay, so this is the optical center. Okay, the principal axis connects the two center of curvatures or the two focal lengths. This is the principal axis, and you have two center of curvatures and two focal points, both for convex lens and concave lens. The convex lens is a converger, whereas the concave lens is a diverger. Thank you, friends.